Hello, so this is a revision video for IB Chemistry S2.2.8, Intermolecular Forces. Intermolecular forces, or IMFs, are forces that exist between molecules. And it is intermolecular forces that get broken or formed when molecular substances change state, for example in melting and boiling. There are several different types of intermolecular force that can form depending upon the properties and type of the molecules present. London dispersion forces, or LDFs, are attraction forces that exist between temporary dipoles in molecules that occur due to random movement of electrons. They are present in all molecular substances, even noble gases and non-polar molecules. There are several factors that affect the strength of London dispersion forces: the number of electrons, the molecular size and shape, and the polarizability. The more electrons there are in a molecule, the greater the temporary dipoles that can form due to their random movement, meaning stronger attraction forces between oppositely charged temporary dipoles in neighboring molecules. The more surface contact there is between molecules, the stronger the interactions as well. Larger electron clouds around molecules are also more easily distorted, again giving stronger attraction forces. Dipole-dipole interactions occur between polar molecules with permanent dipoles, where molecules align so that positive ends attract negative ends of nearby dipoles. For molecules of comparable size, dipole-dipole interactions are stronger than London dispersion forces, and their strength depends upon the magnitude of the dipole moment, so how polar the molecules are, and the distance and orientation between the dipoles, so how close the oppositely charged ends of each dipole can get to each other. Dipole-induced dipole forces occur when a polar molecule induces a temporary dipole in a nonpolar molecule, with attraction between oppositely charged ends from different dipoles. The larger the dipole on the polar molecule, the greater the temporary dipole it can induce in a nonpolar molecule, giving stronger forces of attraction. Equally, the greater the polarizability of the nonpolar molecule, so the larger its electron cloud, the stronger the temporary dipole it can have induced on it, and therefore the stronger the attraction forces it can form as a result. Hydrogen bonding is a special type of strong dipole-dipole interaction that occurs when hydrogen is bonded to nitrogen, oxygen, or fluorine, and the positively charged hydrogen in one of these bonds is attracted to a nitrogen, oxygen, or fluorine in another molecule, or a different part of the same molecule. Hydrogen bonds are highly directional, meaning they can only form with specific orientations, and are relatively strong, meaning for comparably sized molecules, hydrogen bonding is the strongest type of intermolecular force. They result in some very interesting physical properties of compounds, for example giving water an uncharacteristically high melting and boiling point, and cause solid ice to be less dense than liquid water. This is because at low temperatures, so below 0 degrees Celsius, water molecules don't possess enough kinetic energy to overcome the high attraction forces between hydrogen bonding. As a result, the molecules have to arrange themselves to maximize the amount of hydrogen bonding they can form, causing them to have an open hexagonal structure. At temperatures above 0 degrees Celsius, though, the water molecules have enough kinetic energy to overcome some of the hydrogen bonding attraction, meaning they don't have to make the rigid hexagonal pattern, and as a result can get slightly closer together, whilst constantly moving. You may have heard of the term van der Waals forces. This is a general term that's used to describe London dispersion forces, dipole-dipole forces, and dipole-induced dipole forces. Hydrogen bonding isn't an example of a van der Waals force.